Hi guys, welcome to another episode of Learn with Sir Glenn, and for this video we're going to discuss inscribed angles. So let's go! Inscribed angle. Inscribed angle is an angle whose vertex lies on the circle and whose sides are chords of the circle. It is formed by two chords with common endpoint. So let's have a circle with center A. So this is circle A. So let's have point B and point C, which are points on the circle, form chord BC. Then let's have another point on the circle, which is point D. So if you connect point D and point B, you will form another chord, and this is chord BD. So notice that chord BC and chord BD form an angle. So this is an example of inscribed angle. So in our figure, angle CBD is an example of inscribed angle. And since we have here inscribed angle, we also have intercepted arc, the arc inside the inscribed angle. On our figure, CD is our intercepted arc of angle CBD. So the measure of inscribed angle is equal to the half of the measure of its intercepted arc. So therefore, we can say that measure of angle CBD is equal to 1/2 of the measure of CD. So in our figure, if CD is equal to 82, we can easily get the measure of angle CBD by getting 1/2 of 82, which is 41 degrees. Okay, so let's have example of finding the inscribed angle and intercepted arc on our figure. So let's complete the table. So we have your inscribed angle, then its intercepted arc. So suppose you are given inscribed angle BDC. On our figure, the intercepted arc of angle BDC is arc BC. Then let's have given an intercepted arc of inscribed angle, the intercepted arc is arc CE. So therefore, the inscribed angle is angle CBE. Then let's have given angle CBD. The intercepted arc of angle CBD is arc CD. Then you have here the intercepted arc of the given inscribed angle is CF. The inscribed angle should be angle CDF. Then you're given here angle DCB is the given inscribed angle, so its intercepted arc is arc DB. Okay, so now let's try to solve for the measures of inscribed angle and intercepted arc. So given the figure, solve for the following. So find the measure of angle CBD. So in our figure, angle CBD is inscribed angle. So therefore, the measure of angle CBD is equal to 1/2 the measure of its intercepted arc, which is arc CD. So since arc CD is 90 degrees, you just simply take 1/2 of 90 degrees, then you will have measure of angle CBD equals 45 degrees. Now let's have another example. So find the measure of arc CD. Since the given here is angle CBD with intercepted arc CD, then you can say that the measure of angle CBD is equal to 1/2 of the measure of arc CD. So since angle CBD is equal to 87 degrees, we can replace it with 87, giving us 87 is equal to 1/2 of the measure of arc CD. Multiplying both sides by 2, then we will have measure of CD is equal to 174 degrees. So now let's try this figure. So in our figure, find the measure of arc BC. So since arc BC is an intercepted arc of angle BDC, then we can say that measure of angle BDC is equal to 1/2 of the measure of arc BC. So since angle BDC is equal to 34 degrees, we can replace it with 34, which is equal to 1/2 of the measure of arc BC. By multiplying both sides by 2, you will have measure of arc BC is equal to 68 degrees. Then we can now put the 68 degrees on our figure. On the same figure, we're going to find the measure of arc CD. So notice that your segment BD is a diameter, thus dividing your circle into two semicircles. So semicircle BCD composed of arc BC and arc CD. So since arc BC is equal to 68 degrees, therefore CD should be 112 degrees so that you will form your 180 degrees, which is the measure of your semicircle. Okay, so on the same figure, find the measure of angle CBD. So angle CBD is an inscribed angle with intercepted arc CD. And arc CD is 112, so therefore, to get the measure of angle CBD, we just simply take half of its intercepted arc, which is 112. So measure of angle CBD is equal to 56 degrees. Then now let's find the measure of angle BCD. So angle BCD is an inscribed angle with intercepted arc semicircle BD. So since the intercepted arc is semicircle, the measure of its intercepted arc is equal to 180 degrees, and taking the half will give you the measure of angle BCD. So therefore, angle BCD is 90 degrees. Okay, so let's try this one. So notice that the given measure in our figure has x variables. So if we want to solve for the x variable, all you have to do is to use the property of the inscribed angle and intercepted arc. And that is on our figure, the measure of angle CBD is equal to 1/2 of the measure of arc CD, which is its intercepted arc. Since the given measure for angle CBD is 2x plus 8, we can replace it with 2x plus 8. Then we're going to replace the measure of CD with the given measure, which is 108 degrees. So thus our equation will become 2x plus 8 is equal to 1/2 times 108. So to solve for this, we're just going to take 1/2 of 108. So our equation now will become 2x plus 8 equals 54. Then isolate the variable on one side of the equation. So we will have 2x equals 54 minus 8. Then we will have 2x equals 46. Dividing both sides by 2, you will have x equals 23. Okay, so let's try another one. So the same with what we did on our previous example, we're going to just simply make an equation using the property of inscribed angle and its intercepted arc. So in our figure, we can say that the measure of angle CBD is equal to 1/2 of the measure of CD. So since the given measure of angle CBD is 2x plus 6 and the given measure of arc CD is equal to 5x minus 6, then we will have 2x plus 6 equals 1/2 times 5x minus 6, replacing measure of angle CBD and measure of angle CD with their respective measures. So solving for this, we multiply both sides by 2 to negate 1/2, and that will give us 4x plus 12 equals 5x minus 6. Then combining like terms, isolating variable on one side of your equation, we will have 4x minus 5x equals negative 6 minus 12. So simplifying it further, we will have negative x equals negative 18. Dividing both sides by negative 1, then we will have x is equal to 18. So after finding the value of x, which is 18, we can now solve for the missing measurement of your angles and intercepted arc. So let's say we want to find the measure of arc BC. On our given, measure of arc BC is equal to 5x minus 6. So since we already obtained the value of x, which is 18, all we have to do is to replace x on our given measure. So we will have measure of arc BC is equal to 5 times 18 minus 6, which will give us 90 minus 6, and that will give you measure of arc BC is equal to 84 degrees. So using that measure, we can also find the measure of angle BDC. Since angle BDC, inscribed angle, and its intercepted arc is arc BC, which is 84 degrees, getting the half of 84 will give you the measure of angle BDC. So measure of angle BDC is equal to 42 degrees. Okay, that's it. Thank you for watching and hope you have learned something from this video.